Okay. Um, this is not a normal, as you may know by the title, this is not one of my normal videos if you've seen my videos before. But I found this interesting as I'm learning this, and I thought I might as well share with you all. And may shed a light onto a topic that you may not know if you were never taught this in school. So today we're going to talk about I can't spell. Conic sections. Conic sections, right? So let's think about this. What are conic sections? Well, it probably has to do with a cone, right? Conic. So conic sections are where you take two cones that are touching each other on the tips, right? And you cut it in different ways and it produces different shapes. So there are four types of conic sections: circles, ellipses, hyperbola, and parabolas. Parabolas. So let's start with the easiest one first, circles, right? Circles, it's pretty obvious. You just take you take a flat cross section, right? And it's a circle. Ellipses, a little less intuitive. You take a slightly diagonal cross section right there. So it will be like that. And it's like ellipses look like this. They're just like stretched out circles. And of course, a circle looks like this. An ellipse looks like that. Wait, let me put that there. An ellipse looks like that. Next, we're going to take a parabola. A parabola looks like this, right? So it's just a line with a large enough slope to where, with a slope in the right way, to where it doesn't leave this, but it also doesn't intersect this. So I believe it has to be parallel here. And of course, a parabola, it looks like that. And in the hyperbola is where it intersects, and it looks like it's like that, and it looks something like this or this. So yeah, this is just a basic introduction. If you cut up two cones like this, you'll produce any one of these four, or a dot if it's right in the center, a point, or a line if it's across there. But these are the four ways you can split up a cone. So let's look at the equations now. So a circle is always x squared plus y squared equals r squared. And here we're assuming that it's centered at the origin. An ellipse is the same thing, but you can multiply these by any number, right? So generally we do a x squared over a squared plus y squared over b squared equals 1. So here it's just like x is multiplied by a number, so x is stretched out more than y, or the opposite thing, y is stretched out more than x, right? Okay, now a parabola, it's literally just y is equal to a x squared. Yeah, that's it. Y is equal to x squared. So you can see y has no squared, it's only x, which I think is pretty interesting. And then you have a hyperbola, which is x squared over a squared, y squared over b squared equals 1. This is plus or minus, this is minus plus. So it's either x squared over a squared minus y squared over b squared equals 1, or it's y squared over b squared minus x squared over a squared is equal to 1. right? So these are the two ways you can do it. If x is first, then it stretches infinitely sideways. If y is first, if the y is positive, it stretches infinitely upwards like this. Um, okay, so these are the equations. And the final thing I'll talk about is something called foci, which I believe all of these have. Yeah, so if we start with the circle, what's the definition of a circle that you're taught in school, right? You're not taught about all this cone stuff. Uh, like, the first thing you learn about a circle, you're not taught about all this cone stuff, you don't learn about the equation. You learn that it's all points equidistant from this. So it has a radius, and every point on the circle is equally distant from the center. And that's just the definition of a circle. But if you take an ellipse, I'm going to use the tool because I'm bad at drawing. If you take the ellipse, it has two things called foci, right? So the foci are the two points that define these ellipses, and this ellipse is all of the points that are not that are equally distant, that are certain distance called the focal length from each of these. So here, if you have these two, d1 and d2, d1 plus d2 is equal to f, which is the focal length. As you can imagine, as you move these two foci closer and closer together, they go into a singular point at which it becomes a circle. So that's like kind of the similarity between the two. Next, let's look at a parabola. A parabola has a foci here. I was never taught this in school until I'm doing it for summer homework now. Anyways, I was never taught this in school, right? But apparently, a parabola is all points that are a certain distance from both the line and a line and a dot. I forgot what this line is called. There's a name for this line, but this is like a foci, I believe. So if you take this point here, it's a certain distance, d1, d2, d1 plus d2 is always equal to f. That is the definition. Here you take d1, d2, d1 and d2 are always equal to f. And then finally, hyperbola. Let's just use it where y is positive, right? So it's like this. It's like this. The two foci are around here. It's a hyperbola is all points where the difference of the distances, d1 minus d2, is equal to a focal length. So if you take this, the difference of these two are always equal to f, d1 and d2. Here, the difference of these 2 points are always equal to f. So often in competitions and in problems, you may see questions asking about the foci, most notably in the ellipse case or the hyperbola case. You often see foci. You never really see it in problem. Maybe sometimes you do. But this is what foci are. Yeah. And the way you find the foci, maybe I'll make a separate video because it's a bit of a long explanation. But there's a way to find it from the equation of the ellipse and the hyperbola. I don't know much about the parabola actually, but it has to do with finding the focal length and everything. And also I might make a video about eccentricity because I know that's something about the foci. I don't really know what that is, and I want to know more about that. So maybe I'll make a video about that too. So this is just a new way for me to fully solidify my knowledge on this topic while also sharing it to hopefully enlighten some people, to show them something beautiful I found about math, about the relationship between the distances of points away from foci slash center slash foci and line and cones, which I don't know why they have this connection, but they do. So yeah. Okay, thank you guys for watching. I'll see you guys in tomorrow's video. Goodbye.